Hi all, welcome for logging in today. My name is Anup Agarwal. I'm most likely like you, I'm a participant at the Financial Modeling World Cup. And after each stage, I try to improve my game, get new skills, get new ideas, and try to do better in the next stage. Um, I am here sharing, I'm looking to share some ideas, some thoughts, a method maybe about solving certain types of problems using Excel tables. I think I developed this over a few different iterations. While the content and the topic is inspired from the February 2022, actually March 2022 round of FMWC, but the case itself or the solution are not part of this review or our session today. It focuses on a type of problem that we got inspiration from, and so that's what we will be talking about. A brief about what we will do today. Uh, so we are trying to solve flat problems. So a problem where we are focusing on a single dimension, or we convert a problem into a single dimension problem, and then using Excel tables to build it and solve it, model that single dimension. Uh, for that, we will be using Excel tables. So we will talk about a few features of tables that will help us do it. Uh, then we will also review like a few functions and Excel features that we will use today. At that point in the video, you may pause and go through some other resources if you are not familiar with one of or few of those functions. And then we will use all those functions and features to solve the FIFO type inventory valuation problem. Uh, we will go and build a single dimension, very scalable solution that can accommodate a lot of different inventory types, inventory items, and transactions. We will then talk about in what scenarios this solution maybe is useful, is good. And then we will look at another case from August 2021 round of FMWC about option valuation, and a solution where we convert that problem into a single dimension design and then use Excel tables to solve it. Uh, so let's get started on this. So the first thing we will do here is review Excel tables. So this is what we are going to do. You might have been familiar with Excel tables. So let's say if you have some students, let's say 5 of them, and their scores out of, let's say, 50 in an exam. This is the data on a regular Excel range, but we can convert this range to a table. I select the whole data, press Ctrl plus T on my keyboard. Excel asks me if I want to create a table and gives the range. This is what it's looking at. And then, yes, my table has headers because the first row is the heading of the table. Now this converts this into a 2 by 5 table with headers in the first row and data in the other 5. It has a name. You see it whenever I am on a table, it shows this table design part in the ribbon, tab in the ribbon. And now I can give this table a name. I'd like to start my names like TBL and let's say scores or score. Okay. Let's call this name and score. I also, somehow like this to look at this better. One obvious advantage is tables can very easily make your data look better. Okay, but we are interested more in some functional advantages, which I have listed here, but we will talk about it. So yeah, first is once this data is in this table, you can add, of course, more features, or sorry, more columns here. So if I simply write here percentages, the table expands. Or if I add another student here, the table automatically expands. Or I can use this to expand this, add more rows or add more columns. And let's say if I say that the student has a score of 32, yeah, this data is now part of this table. What this whole thing helps us do is, let's say somehow I am interested in the average score. I can write a formula as average of the whole range. I can come here and select this whole thing, or I can be on any cell and press Control Space to select the whole column. And now you see this range, which is actually C12 by C17, is automatically named table score, which means it's the score column, what comes in square brackets, of the table score table. And so the whole column, it's the average of those numbers. So this is the average of this. So now you see it becomes a little bit easier to review formulas, not such simpler one like this, but more complex ones also, that instead of looking at a range and trying to figure out, okay, this is what it means, you can very simply see, and yeah, this is the average of the score column. These type of things. Another, so yeah, this is the first advantage that I really like, is you can have automatically named ranges when you create tables, or more easy to name ranges. And then these ranges are very dynamic. So if I had another student over here with some different score, the average updates. Yeah, sorry for that. Okay. Yes. Okay. Now, the second feature which I really like, which will be very useful, that if I write a formula in a column, let's say I want to calculate a percentage. So these scores are out of 50. I say divide by 50. I press enter. That formula automatically goes into all the different cells. So if for some reason I had to edit a formula into something else, I don't know, let's say these scores were out of 60, and update one of these cells, all the rows in the columns, the formulas update. This is actually, can be very, very handy when, let's say now if I am adding another student over here and they have a certain score, this updates, or this flows through the whole data. I'll give you another example here. Let's say I'm interested in the ranks. So I say over here in this column, I name it ranks, and I use let's use this one, rank average, this number, and then looking at the scores of all other students. And I do this. Again, this flows through the whole column. Actually, let's use the other one, rank equal. Okay, so that we don't get decimal points in rank. Let's say this is how I want formatted like this. And now let's say if there is another student. So you would have seen I use the whole range to refer to this. Now, if I were to add another student over here with a certain score, this reference range also expands. If you spend a little bit of time with this, you will get familiar with the way these names are appearing. I usually not try to type these, but simply navigate using my cursor keys to go to the cell which I'm referring to. However, if you want, you can also type something like rank and then let's say table score and square bracket and select a column and so on. I find it generally a little bit, more, I would say, effortful, and it's easier to navigate. So yeah, this is what we will be focusing on, using these Excel features to our advantage today. Another very little quick thing, because this is all in Excel table, it's easier for Excel to recognize, like what the data is, what the header says. And so I can now very easily apply sort, etc. to this data. And similarly, if I use filters, it just picks up the whole range and the whole table. And so when we are expanding this further, it becomes part of this new sort and new filters. You of course have to do the sort again for this to show up correctly. All right. So let's also now review, apart from tables, what else we will use today. So we will be using the Excel tables, which I just explained. We will be using the sort feature here on Excel. We will be using a few functions, very common ones, min and sumifs. Then our favorite, index and match, my favorite, index and match. The if function, if error function to plug some errors. You might or might not have seen the row function, which actually very simply, if you were to write this over here, it tells you that this is the row 16 which you are in. That's it. We will be using a few mathematical operators, of course, multiplication, plus, and divide. There will be some other functions which we will use in other solutions or alternate solution, which is not the main solution which we will be looking at. And then we will be looking, when we review the second case, these are some additional functions which we will look at. So I don't think the list has any exotic, difficult functions. If you are unfamiliar with any of these, I would suggest you pause the video and look for some resources to go through what these functions do. I believe they are very, very handy. If you use Excel 6 hours a day, most likely you will touch them sometime in your day. And I'm pretty sure they will make your life easy, at least these ones. All right. So let's now go to our first case study. So this is the case I draw. So I built, drawing the inspiration from this month's financial modeling World Cup case, where we try to value inventory using FIFO or LIFO method. The case focuses this one on the FIFO method, but you can of course change this or edit this or build this to a LIFO method. A few features here. So let's say we have a bunch of transactions. Here actually we are doing stocks, as in shares, instead of inventory of products. So let's say you are buying and selling shares and you have different transactions on different dates. So there are multiple stocks or multiple shares that you are trading in, different dates and different quantities. There is no constraint that the dates are month-end dates. So we want to be able to measure the inventory on any date or any period we want, or the cost up to certain dates and these type of things. There are multiple different tickers, of course, different shares, and there's no constraint on quantities. So the quantities are not in like big round numbers or in multiples or the same multiples in which you purchase them. So these are any number of shares that you can buy and sell. Our solution or our method focuses on how to value this inventory using FIFO or first in, first out method. Let's say this is the data that we have. We have dates, the stock in which you made a buy transaction, how many units you purchased, and at what price did you purchase. So you see these transactions go on from 2014 to 2020. Now, multiple tickers, and then the units and price. The units are all round number, even though the way we will build it, it doesn't matter. So if those are like units in a security in which we have fraction, the method can still work. The prices are of course in 2 decimal places. I think in some places there are 3 decimal places. I'm not sure why I got this prices from a pricing service. All right. Then similarly, these are the sell transactions, different dates, different stocks, the number of shares that you are selling, and then the price at which you sold them. These red columns, so you see like the problem is already depicted in tables, but yeah, so these red columns in the table, it's this answer that we want. So we want to be able to measure what is the how many units of these individual purchases do we still have in stock, and what is the cost of that inventory. So the sum of these columns would really be your closing inventory at cost, not at market value, at cost. And then similarly on these transactions, let's say this 20 units that you sold in 6th of February 2015, what was the cost at which you purchased it, the total dollar amount, and then the gain or loss that you made on this particular sale. And similarly for each of these, we want to measure the gain or this loss on sale. Okay, so first let us build a regular multi-dimension solution to this problem. And then, I'll talk a little bit about what I really meant by multi-dimension and single dimension solution. So let's say, because you see, you cannot buy Microsoft stock and sell Google stock from that stock. This is really non-interactive. So I would, let's say, focus on a single ticker. I sorted both of these tables such that I get all the same stock together just for ease of calculation. Okay, so let's just focus on the Apple stock here. These are all the buy transactions and these are on the sale transaction we made. So it is actually, I think, pretty straightforward to build a multi-dimension solution here. Let's say I put all the buy transactions here. And then all the sale transactions here. I will make this a little bit like this, let's say, to make it easier to read. Let's put the header also in here. So just to be sure, I'll write these are all buys, and then let's say here these are sale. Okay, and so this is actually pretty much the official solution to the case that we had, which was that you can write over here a formula that can figure out or match that each of these individual buys, when were these sold. So I could write, let's say, smaller of, let's say I start with writing like this and this, but then I can also write that this really represent the stock which has not been sold. So like this. So, okay, just before all that, I forgot to mention that these dates are in ascending order to represent the FIFO. So the first buys are matched against the first sale. So we are saying whatever we bought first are the first that to be sold. So this 45 that we bought, we sold 9 of them here in April 15, and then 19 of them July 15, and then so on. And this is how we sold them over time. You see over here in this period, in September 17, we sold 15 shares, but the stock which was left from 45 was only 9. And so some of this was sold over here in this period. So it came in from this inventory. So 22 of this was sold over here. None of it was sold over here because everything that was sold in these periods came from April 2015. So I would do a little this here. And you see it sort of creates a staircase pattern where the first stock gets sold first and it's completely exhausted, and then from the next it goes, the next few sale, and so on. Sometime it may just happen. So for example, if you sold a lot in this period, this formula takes care of it, and so this sale will come from a few of these multiple things. And so you can now do a few sum products on this to figure out what is the gain or loss or the cost of sale in different periods. So this is a multi-dimensional solution, or how I am referring to it as a multi-dimensional solution, is because we have sale on one dimension and then buy transactions on another dimension. So horizontally, we are looking at sale, and then vertically, we are looking at all the buy transactions, and then we are mapping or solving or building this in this grid fashion. Another way to look at it, or another dimension to add to this, you see, like this is for the Apple stock. We have in this example 3 more stocks to look at. So you would have to draw grids for each of these stocks to let's say add another dimension to this problem. So there's a horizontal, vertical dimension, and then there are different stocks that you can layer to on this. In this particular kind of solution, you can actually layer these different tickers in the same 2 dimension. Like we can solve it just with 2 dimensions, but then that solution will grow really, really big. You see, for example, you'll have to put in all these 40 purchase transactions here and then 40 sale transaction here. So it will make a 40 by 40 grid of formulas like this. You'll have to add a little more conditions to it to check the stock versus the stock to make the correct match and sale. But yeah, still that solution will be a little big. Now, what I mean by single dimension is, you see, like in a table, there are multiple characteristics, but you only have one dimension to expand on. And on that dimension, you have these multiple characteristics. So in this case, you can say that the sale transaction is that one single dimension that we are focusing on. So all these sale transactions go and as different rows here in this table. And then the number of units you sold, or the price at which you sold, or what is the gain on that sale, are all characteristics of this single row in this example. And so we are looking to, or I am suggesting that we want to convert this problem into a single, or this solution into a single dimension solution, where we can very simply build a large table, or like a manageable size table, where each of these, these sale matching is actually a single row for our table. And our table can very intelligently say, or not so intelligently, but with help of Excel formulas, say that, this 14 of sale is actually out of, is you sold on 24th May for $19, for $47, and you had purchased these on 18th September for $39. And so these are, what are these? I think close to 12 or 15 different rows for a combination of buy and sell and that is what we want our table to be able to see. So we will now build that solution. Okay, so to start building the single dimensional solution, I will start with copying the data. Let's say I copy this column or this whole table and put this here. And let's say I copy this whole table and put this here. Let's freeze pane. So really, this is just a copy of the problem. I will rename this table to something that I want to work with. And then before we get started building this solution, I'll try to show you the logic with which, or like what I am trying to achieve here. So I'm looking to build a single dimension table over here, which is a combination of buy and sell transaction, and really want to show here or like calculate automatically that table sell. So for each of the sale transaction, so the table sell row, let's say this first sale, the model will, or the method will calculate the table buy row automatically, that this is on the first row. So this first sale is from this first purchase, and then the combination units or the allocated units, let's call it com units, are these 9, which is like 45 of purchase and 9 of sale. So the 9 of sale of table sell row 1 comes from the first purchase, or the first row of purchase. And then on the second sale, also comes from the first row, because 45 minus 9 leaves a balance of 36. So you have 19 to sell, so it will sell 19, and then the third sale will come still from the first row. It can come all the 3 units. So right now we have sold 31 of the 45 units. We have 14 units left, and so the fourth sale also can come from the first row, which is the 5 units. So we have 36 units sold, and then the fifth row or the fifth sale also comes from the first one, and now we have a balance of 9. So all the 45 units of this are exhausted, and then the sixth sale, which is this one, the fifth sale, part of it comes from the second row. So of the fifth sale, 15 and 9 has been allocated, so we have 6 units left. The second purchase was 22 units, so these 6 units can come from here, and then the sixth sale from the second unit, I think it's this transaction, and I think it would be like all of them, and so on. So we want this table to be built formulaically, like, and not somebody manually inputting this, so such that each row of this table is each of these on the multi-dimensional solution. So it's like a flattened view of this, and we will use formulas to build this table, and really we will try to build it in some way that if there are more purchase or more sale transactions, expanding this table does everything else. There are no other manual steps required to do this. So this whole design of planning, this takes a little bit of, I believe a little bit of thought process, that what you want or what will be that one dimension that you're trying to work on. And then a little bit, of course, if you do it a few times, it becomes a little easier to get into this mode. So yeah, we will try to build this table. To make this work, we will need a few helper columns on these. I will add them here as a serial number. To add the, let's say, a serial number on this table, I just go on this table, go resize table, change the definition of this table to include the column B. So now you see this column is added to this table to the left, and I call it SR as in serial, and then I format this to look like this, to tell me that this column only has formulas, and whenever I am updating this or doing anything here, I don't need to worry about updating or editing this column. These are all formulas which will all update by itself. And I use the Excel's row function now to add a serial number. When I add row, it tells me that this is row 6, row 7, and so on. And when I, let's say, subtract the row of the the row function and the input in that formula, or the argument in that formula, is this range, or it could be just a single cell on this table or this header. This now gives me row numbers from 1 to 40. And now I do the same thing over here. Let's say this time I type the header first. Yeah, that was a mistake. I didn't want to click on the Power Pivot window. I wanted to click on the table design window. Resize table, include the column J in the definition of the table, and then write the same formula. I can write this cell be the last cell as well of this table, and then it automatically fills all this. So both of this tell me there are 40 rows on each of these tables. Yeah, I'll format this also, in green. Now I'll create a serial number table, serial number column here also. And so you see, like, this row and this row are really the same thing, sort of like a primary key of the table, which we will use to refer to and identify. Again, the solution which I'm trying to build here, this only works if the data is sorted by date and then by ticker, such that the same stock is together. We can build it differently, where it can still work on slightly different sorting, or like something which is absolutely random things. But for now, for a simpler solution, I will build something which works on data like this. So first, it is all the same stock is together, and then all the dates of that stock are already in FIFO order. So the formula can very easily pick up the first row versus the first row. All right, so I will turn this thing into a table, a control T. This is the whole thing, and this is, yes, my table has headers. I will change the formatting a little bit to look like, let's say like this. I'm making it green because the solution part of the problem. I will also remove these extra rows. Let's say we work without them for a moment, but let's say we keep just 3 rows in this table. Okay, so the serial part is, and also take out this filter buttons from here, makes it easy to read the headers. So I'll write a row minus row. Yes, naming of this table, I call it table combination. Yeah, table combination, that's it. Okay, so now we want to write a formula over here which will say that if, which really we want to work on one row at a time. So all these 40 serial numbers have to appear over here. That is the first thing. Second is, some of them may appear multiple times because, like in this example, this sale row will have to appear twice. So some of it is sold out of the first batch, and then some of it is sold out of the second batch. So let's say I start with a formula that if this serial number is 1, it is 1, otherwise 0. Give me a moment here. I'll change my settings a little bit. Okay, I expanded the font size on this so that it becomes a little bit easier to read while you're reviewing this video. Okay, I will also remove all these manual things that we did sometime back. So yeah, these are our formulas. Okay, so this formula gives us a serial number. Now let's say I write a formula over here that if this is 1, then we want 1. Otherwise, just for a moment, let's say 0. We'll work on it in a few moments. Then the table by row. So where we are trying to identify that which row of this table is the Apple purchase, because the sale is for Apple. I'll add a column over here. Let's call it ticker. And I can now write index this. You see, this works because the serial numbers are exactly the same as the row numbers. So if I just write an index, the first one, it picks up the first cell. And so it says that the ticker on the cell row 1 is Apple. And then let's say I write table, or let's say cell units, where I want to say, actually I want to say how many units of this sale is still unallocated. But for now, let's say the whole sale is unallocated. So I write this formula like this, cell nothing. Let's actually just make it like this, such that this spell does not distract us. So I reduce the table. So these are the cell units. And then the table by row. So the Apple stock is on the first row, but we want to get that from a formula. So I'll write minifs. What is the first serial number where the ticker is Apple? Okay, just to remind you, I am pressing to select the whole column. I just go to a single cell in that column and I press Ctrl space on my keyboard, and it selects the whole column. And so I don't have to type that, table by ticker column. That comes by itself. Those are the automated named ranges. Okay, so this is the table by row. I'll also get, by units. So it's like how many of these 45 units are left to be allocated to a buy sell combination. For a moment, it is all these 45. Sorry for that. So table by row. So this all these 45. And so on this transaction, which is like the first row of buy and the first row of sell, 945, the matched units are the smaller of the two. So this 9. So this 9 really means this 9. And so all these formulas actually, will be updated a little bit for us to calculate the other coming rows. To help us in doing that a little bit, I will say that, post this allocation, how many cell units are remaining to be allocated? In this case, it is 0. And then how many buy units of this purchase let's say post are remaining to be allocated, which is 36. So of the first row, we have 36 units still balance. And then of the first sale row, we have nothing as a balance. So everything has been allocated. I'll format it like get read zeros as dashes. Okay, so now for the next row, we want to now intelligently look at, is it time to go to the next cell row or not? And so over here, I'll write a formula that, if from the previous sale, if the unit post the cell is 0, then it's time to go to the next row. Otherwise, we still need to work on this sale row. And so if I write a formula over here, it takes us to the next apple row because it's now time to work on the next apple row. And so the balance of those units which are to be sold is 19. Let's now look at this. So the first buy row is still, is what we want to work on or work with. But, it is not because it is the first row. It is because we still have balance and it is the same stock. So I'll probably write over here that, if this stock is something new, it's not the same as the previous stock, then, we want to pick up the first row of the buy table with stock. Otherwise, if the number of buy units have been depleted, then from the buy table, we move to the next row. Otherwise, this W6 table has some balance. Sorry, this W6, the cell W6, the buy row it is referring to, or the row 1 has some balance with which we can work. So let's work with that. So I can write a formula like this. And it says that, yeah, it's time, or like we still want to work on these units. So the table by units now is that, right now we are picking up index, or like how many units are over here. But I'll now change this formula that, if this row and this row, or this row is picking up from the same buy row, then the balance of the units from this buy yet to be allocated is actually 36, not what you see on the buy table. If this is a new buy row, like let's say row 2, then of course, yes, this is the balance of those buy units is from the buy table. So I write a formula like this. So you see like now this balance of 36 appears over here. As we have 36 units available to allocate. So now the formula does a min, which is of the 19 and 36. It has allocated row 19 units. And so we have a balance of 17 on the first buy row and nothing on the second sell row to allocate. Let's say I come here, press tab. It takes me to the next row. I think this is working correctly. I press another tab, and I think this is also working correctly. You see the solution is same as this, 91935. And then let's say go to this. So you see like we only have a balance of 9 units in the first buy row left, and this has been allocated, but we have now 6 cell units yet to be allocated. So I press a tab again and see if this works correctly. Okay, this broke a little bit over here. That out cell unit over here. 9 have been allocated in the previous step. And so we only have a balance of 6. So I think I will change this formula over here. That if this cell row is the same as this cell row, then these are the units which are left to be allocated. If this is a new row, then of course it's fine. You pick from the cell table, and I close this over here. So now this says that there are 6 balance over here, and it picks from here. Now in doing all this, I don't think I mentioned that, when I updated this formula, it updated the whole column. So whenever I was updating any formula anywhere in this table, it updated all the rows in that column. So that makes it a little bit easy to update. And then of course, when we are adding new rows, the formula from up get copied. So now if I were to add these many number of rows here, I can also pick this little thing and pull this here. Let's just keep it up to these rows. I will delete this. So this is all this allocation. So you see this solution is exactly the same as this solution. And now the way we have written this here, I can expand this to a certain number of rows. Actually, I do not know exactly how many rows for now. My favorite way to do it is to pick a column and copy it down. At a certain number of rows, when all these buy-sell combinations are done, the way we built it, it will go to the next row, in this case row 41, and tell you, dude, there is no row 41, and it says, there is no 41st item in this ticker table. And here is where I'll say that if there is an error, delete. So this thing, when I'm looking at, it tells me I don't need these rows. So these are the number of rows, or all the rows that the combination just allocates all the purchases to all the sale. So this is a one-dimension solution of this exact solution. So this is finding this out on 2 dimensions, and this is finding this out on 1 dimension. The advantage of this is that if I have new purchases and new sale over here, I need to add this table to do this. And instead of, in a 2 dimension, in this particular scenario, I would have needed a 40 by 40 grid. In this case, I can do it with 48 rows. And I believe this can really quite efficiently use this. This is a little bit more complicated, of course. And then if it is not built correctly, it can have errors. We'll probably build a few error checks, or in this particular case, my error check is really that, I'll call it allocated units, or let's say combi units. And I'll do a sum ifs on this, where the cell row is the same as the serial number. I had a minus over here, which we don't need. And then I'll do what this minus this, this minus this. And if it is all 0, it really means that, this 16 has somewhere been allocated over here in this combination unit. And so this 16 sale has been mapped to some purchases. And so if all of these are 0, this really means we have done our job right. Over here, I'll probably add a helper column here called sale units. I'll format it like this, and I'll do a sum ifs here on the combination units, where the table by row is this. So it really tells that, of these 45 units, all 45 have been sold, and the balance units are 0. So we can format it like this. And then the price, this is price per share, not the total value of the purchase, multiplied this. So this is the cost, or the FIFO cost of all your holding. There is a rendering problem over here. These cells do have numbers. I think my Windows beta is giving me some problems. Okay, and I'll also format this as green to tell the user that, this is all a formula and it all updates by itself. So if I were to add some few more purchases over here, this will expand and give me an answer. We'll probably try that in a few moments. Okay, so now we want to figure out what is the cost of this sale. So for that, we will need a few helper columns over here to tell us, let's say, okay, I'll type in over here cost per unit. And so, sorry, not here, here. So this is the buy price of this purchase. And so the total cost, I'm pressing a Control R and it copies. I think I find it is a little easy. So I say cost per unit multiplied the combination number of units. So it means this 9 units are sold at, sorry, or were purchased at this price, 32. And so the cost of sale is sum ifs, all this cost of all these sales. And so the gain is, let's say, this multiplied this. This is what you sold it for. Let's actually add a helper column here for, sorry, sale value, which is units multiplied price. Let's format it like this. Sorry, not the whole column. This and this also. So yeah, sale value this minus this. So this is the gain you made on these individual sales. All right, and I'll format all these green to again tell us what is going on over here. Okay, so you see, this is what we wanted, that we could get the answers to this. The steps to do this is to figure out what you are selling out of what. Instead of doing it multidimensionally, we did it on single dimension, and then we can add some details on this single dimension to figure out all these answers. Now let's say on a certain date, today, you sold some Apple stock, 20 shares for certain price. Please don't take this as the price advice. I have no idea where the Apple stock is. And then let's say another one on this date, you sold some Microsoft stock at certain price. You see, the combination units gives you an error to tell you that, this table is not working correctly. To make this work correctly, I will do the same thing. First sort by date and then by the ticker, so that all of them are together. So these are the new transaction which we just did. And then to make this work, all we need to do is to add a few rows on this table. And that's it. The combination units are here. So all those additional sales that were made on today, or like at today's date, they all have flown into this table. I can choose to delete these rows, or I can leave them. I think I should delete. And then, yeah, it is a neat, nice, expansive solution. Let us now review what we just did. So we took a problem where the general solution is a multi-dimension solution, and we put this as a single dimension solution. And let me give you my 2 cents on, when or how this can work. So I believe this method has a few advantages. It helps in easy expansion of data. So if it is something that you are gonna work on again and again, and you are more interested in the results rather than the method, so you can create a little bit of black box method or a more difficult to review method, but it is easy to add new data. So the tables take care of all the formulas, all the links, all the any new data that you add, they all automatically flow into everything. Uh, in this particular problem, the only manual step for adding data would be to expand this combination column, which will take, like a copying and then deleting a few rows, which is actually a very, very simple VBA code that you can do. Probably, there could probably be other ways to achieve that. Uh, in this particular case, you can leave those extra rows and it doesn't hamper the solution, of course. So yeah, something like this. You can probably do a few error checks over here to, instead of showing this spell, maybe they will show 0, these type of things. Okay, and then let's say once you focus on the basic problem and then you have converted or figured out what is the single dimension method of this, and this is how my result would look like. It is easier to add more rules, improvising this solution. So every time you can add few more, like how we build this solution today. We built a basic solution, but then we improved with the problem as they expanded. But there could be, much more complex rules around, let's say, this actually comes from because I use a similar method to figure out some of my personal investments and the taxes and stuff on that. And there are some complex tax rules on the difference between the date of purchase and date of sale. So there are different tax rates on it. Sometimes there are different deductions allowed depending on when the stock was purchased. And so these type of rules you can build into a table like this. So it may just be that a sale that you made on a certain date comes from a few different purchases on a few different dates, and they are because they are in different purchase periods, they can have different tax impacts. So a solution like that can be built, I believe, easily into this design, and I think it has been working fine for me for now. Then other inventory methods, like let's say LIFO or something, like you have a little bit more complex rules that if the buy and sell happen on the same date, then they must be allocated first. Otherwise, it is on a FIFO basis, and these type of different things. It's easy to build those logic into these formulas to include those. And then I believe those are more complex to implement in something like this. There are, of course, costs of doing this. First is this method requires a little bit more planning, a little bit more clarity of thought that what you want to do, and if and how you'll be able to achieve this. This, of course, requires a little bit more knowledge of Excel formulas and features, such that the logic that you have in your head, which you can explain to somebody manually, you have enough words and formula power to convert it into an equation. And of course, if those formulas are badly written, so for example, I believe this is a good solution. There are some very few formulas which refer to entire ranges. For example, this one, where we use a minifs on a very large range. So if you had, let's say, 50,000 transactions of buy and sell, then this formula would need to look at 50,000 rows to come up with a solution. So if this was badly written, a lot more of these formulas would refer to very, very large ranges and large data, and that can make this a very heavy solution. Apart from that, I think this solution would generally be lighter than this solution. And then, of course, when you are building something like this, it's not for a test situation. It is on something which you will be reviewing and working on a lot. And so it really works in like a portfolio solution, a personal portfolio solution, where You want to be able to update your transactions every now and then, and to get your tax reports or track your portfolio value and these sort of things. So yeah, that's for our inventory case. Let's move on to the next case. For the second case, we will be focusing on the method rather than building the solution. So we will be reviewing the thought process of converting a problem into a single dimension solution, and then reviewing that solution. So we'll not be building that, but you will have that available. By the way, this file which we are working on, you will get a link in the description to get this file, and you will be able to review everything that we did today, and these formulas and everything that we built today. Okay, so this is from a case that appeared in FMWC August 2021, so the previous season in the August round. And this is actually I find it a very fun financial exercise, a method that explains a concept really, really well, which is around pricing of options, where you simulate the price of a stock, and then you figure out what the price of an option is on that. So this is like a very niche finance problem, and then a binomial method of solving it to reach the results. So if you're not familiar with this, maybe it's great to review this, or you can go to the FMWC timeline on LinkedIn and review the materials they provided in August 2021. I think it's a great note. So it's actually, I believe this is what it's called. So, okay, so this is a brief review of this, or like a brief words about this case, that you have a stock price and then some parameters to project different scenarios in future that where that stock price can be. There are then rules on the options that, if the stock price is more or less than a certain number, then the option has this value or this payoff, or this is what you receive in cash from owning that option. And the method works that from today, you figure out future at different months. So let's say this is January, beginning of January, you figure out what could be the price at end of January, and let's say end of Feb, end of March. So every future date, the price depends on what it was on previous date. And then let's say the option only expires in June. So you will first go on forecasting what the prices can be in June with different probabilities. And then you trace it back that if June has, these many different probabilities and these prices, what is the price of the option today? And this involves, projecting those scenarios and then discounting at each of these different time periods. So I will start with a problem where actually these are the main inputs, these orange cells, a certain stock price, a certain risk-free rate or discount rate. For this demonstration, I'll just be using some non-technical words to define this. Otherwise, there are more technical words for these probabilities and discounting and compounding factors. Okay. So, and whatever words I'm using are a little simplistic, but I think it helps explain them. Okay, so then this is the strike price of that option, and then what is the time? Using these inputs, again, there are some mathematical relationships. For now, let's say these are given, that in an upside scenario, the stock moves 1.02 times, and in downside scenarios, a stock moves 0.98 times. So from beginning of January, the stock can only have two outputs. Either it can go up or go down, and these are the probabilities of it going up or down. And then this is what how many, or the multiple where it will go up or down. I'll just change these numbers. So give me a moment here. Something is wrong on this cells. Let me fix that. All right, so this cell is referring to the wrong cell. Okay, so yeah, let's say these are also input for this exercise, that these are the probabilities with which this stock can go up or down, and this is the factor with which it will go up or down, and then each month or each period, it will be discounted by this rate. And so the question is, what is the option price today? This is the textbook solution to the problem, which is where you build a pricing tree, which says that, if this is how it looks like today, this is the stock price today, and then tomorrow the price can go up 1.07 times, or it can go down 0.93 times. The next period, this 697 can either go up 1.07 times or go down 697, can go down 0.93, which is same as 606 going up 1.07 times. So the down from this part and the up from this part are actually the same. So this converges. So the first leg has one possibility, the second leg has two possibilities, the third leg has three possibilities, and so on. And so in 5 time periods, there are 6 possible places where the stock price can be. And then the option can only be exercised at this period. And so if it's a call option, then there is mathematics to tell you that, if the stock price is 992, then the option price is 282. If the stock price is 802, the option price is 162. And then you discount it sort of backwards. So this 122 is this 162 and 57 multiplied their respective probabilities. So this 162 multiplied 62%, and then this 57 multiplied 37%. That's the weighted average expected value of that option price. And then you multiply it with a discount factor of 0.98 to bring it earlier in time. And then this process goes backward all the time. And so you reach a certain option price today. I'll show you how the logic of this flows. So we know the stock price today, 650, and then this drives or mathematically determines what's the stock price in the next month, that determines what's the stock price in the month after that, and so on, and you reach what are the stock price possibilities in month 5, and then from there, that tells you what is the option price possibilities in that month 5, and then you discount it. First you add them up using the probabilities, and then you discount it to get what's the option price in the previous month, and then the option price in the previous month, and the previous month, and that's how you reach the option price today. So this 650 sort of flows downstream to reach these numbers, and then it comes upstream to reach the option price. So for me, these individual leaves, I'm calling them leaves or branches of this pricing tree. Sorry. And then each of these branches, I look at them as that single dimension which I want to focus on my table. And so that is how I will convert this problem into a flat problem, where it will become easy to add more complex roots into something like this. And then probably it will become easy to add more legs to this transaction, because you see, like if somebody now tells me that I want to model a 6th month, it will probably look something like this, but then there are a lot of formulas to fix over here and then over here. So yeah, I believe, we can avoid all that with a single dimension solution where we can accommodate different types of options, and even we can accommodate, American or European options, and uh, even more exotic rules. So this is that solution where each row of this table is a leaf on this. So this is the first row of the table. Then this is the second row. This is the third row. This is row 4, row 5, row 6, 7, 8, 9, and so on. And so this is our first column to identify what is the table number. I'll leave these panes over here for us to easily review this. Then you see I added a formula over here to figure out the first row is times 0. So the first row is times 0, but then the second and third row are times 1. The fourth, fifth, and sixth row are times 2. I use this formula to do this. Actually, I figured it out using this equation. So if you're familiar, what is the total number of some of these? Like if there are 3 time periods, how many leaves there will be? So if there are 3 time periods, if you put in this equation, 3 multiplied 3 plus 1 divided by 2, that will give you 6. So that tells you that, you need 6 leaves to make 3 time periods. For 5 time periods, you need 5 multiplied 5 plus 1, which is 30 divided by 2, 15 rows to fix this. And then I back calculated the equation. So putting n in terms of Sn, and that is what this equation is. So that turns these row numbers into which time period it belonged to. And then these parts where that, which leg it is. So this is leg 1, leg 2. This is leg 1, 2, 3. This is 1, 2, 3, and 4, and so on. Then I added an identifier column because I wanted to make it really dynamic, such that if the user selects these are 5 time periods, they will get 5 here. But if the user selects it 6 time periods, it calculates for one more, a certain number of rows, and then it figures out the prices based on that. I'm setting it back to the 5 time periods such that the identical results are this. Call option. Okay. And then I created some helper columns over here for me to identify that, the leaf 2 of this leg, or this is the leaf 2 of the first time period. Where does it get its price from? And it gets its price from over here. And so it is saying that, for the previous period, what is the down row, which is which row of this table is the down direction from this. So for over here, the first row of the table is the down direction. For this row, there is no down direction table, down direction row on that table. For this one, this is the previous period's up direction, previous period down direction. And for this same one, this is the next period up direction, next period down direction. And this is what these 2 columns, these 4 columns are helping me with, that previous period up row, down row. And then I can use some indices to figure out what was the stock in those periods and what the stock will be in this period. So this is to identify what is the stock on this row. So this 860 is same as this is the 4th time period, first leg. So 4th time period, first leg. This is the stock, which is determined from the previous period multiplied 1.02 times. So this 860, this formula, I'll expand this a little bit smaller. So this formula takes care of that it's getting it from the row 7, which is this one. So the 3rd time period, first row, and multiplied 1.07 times. And so there is more logic over here, whether it is good to exercise now. So there is option to convert this into an American option or a European option. So if I set this to the call and for this whole method, the multi-dimensional solution, now this is identical to this single dimensional solution, and this first row over here tells you what that price is. I also created a little bit of check over here just to help me understand when I was building this that I'm reaching the right numbers. So this table, even though the presentation it looks like this is no calculation, and it is drawing the numbers from this table using always indices to say that, this is the fourth leaf or fourth row, and what is the stop price and what is the option price, and such that I can compare this with maybe this, though to tell me that, I got it all right. It's a little bit difficult to review your results from here, but then once you are confident producing solutions like this, it can be you can use it with more confidence and to build very dynamic solution. So this can be very, very easily expanded. If somebody told me I want to build a 12 period this thing, I'll have to expand this to enough number of rows to reach those 12 periods. I think that ends over here. So this table now calculates this option price using a 12 period tree from today. I will leave this with you to review. Probably this thing will help you. Supposed to be, and I think it was a nice dynamic solution. It may still have a few errors. I have not used it professionally. I only used it as an academic exercise. So I would suggest you don't use it for any sort of professional work. But of course, you're free to review this and learn a bit, probably. I think yeah, that is all what I wanted to present today. Again, this file will be linked to the description of the video below. So you will be able to download this file and review everything we did today. I thank you again for your time. Maybe if you have some questions, other thoughts, please leave them in the comments. I'll try to answer them. I'll try to improve maybe something in future. And if there are ideas for some follow-on things that you would like to see, I would love to hear your thoughts. Thank you so much. Goodbye.